Hello and welcome to the third lecture in our comprehensive data science, machine learning and artificial intelligence course. As I earlier said also that we are at present just building up our Python foundation and that will continue for several lectures. So in this chapter, we want to discuss about built-in data structures, then we want to discuss about object-oriented programming, and then we want to discuss about GUI building, graphical user interface building. Okay, because from there the student starts feeling interested when he sees that some actual small app is being developed and it is displayed on his screen, then he feels being interested. Otherwise, whenever code just goes on running, but that is code is very powerful, but it is just abstract things. I mean, nothing visual is produced by a code. It will just executes in a Jupyter cell, and you may at the most print the output. Okay, but that will come later on. At present, let us focus on only first part, built-in data structures. Now, we want to focus on these data structures in Python, which are called collections. What are collections? Then collections is a combined name for four types of data structures in Python: lists, tuples, dictionaries, and sets. If you know these four, then you can tackle 95% of the programming related questions. Okay, so we will discuss here. We will delve into this list, tuple, dictionary, and set. So let us first take the first one, that is list. Okay, and okay. Now lists are ordered collections which are mutable. So what is the meaning of each term that you should be understanding clearly? Ordered connections means what? We will discuss it. And mutable means what? That also we will be discussing. Okay. Now here I have changed. I have already described in short. Ordered collection means its element. Mutable means that its elements can be changed after the list is created. So suppose this is one list has 3 strings inside, and I want to change the element whose index is 2, that is this Arya. Then I can easily change by writing name list, then in square bracket 2 equals, suppose I want to make Arya to Aryan, by mistake someone has written a boy's name as girl, then I can just write name list, then in square bracket 2 equals Aryan. Okay, and the list can be changed. That is the meaning of word mutability, that is individual elements can be changed. And second thing is, even after you add, you can even add elements, subtract elements, but the elements can be accessed always by the same index. That is, they maintain their order. That is the meaning of word ordered collection. Okay, so they maintain their order unless you of course explicitly change the order. So that means if I add a new element here, currently Alia can be accessed by 0 index, Mira can be accessed by first index, and Arya can be accessed by first index, second index. If I add a new name at the end, then the new name is always attached at the end unless you explicitly put somewhere between. Okay, so if you use a function called append, then it will always append at the end. So suppose the fourth name is added at the end somewhere here at the list, but that still Arya is accessed with 0 index only, Mira will be accessed with first index only, and Arya with 2 index only. So that means the index by which the elements were accessed, or the order by which the elements were accessed before appending a new element, and the order by which they are accessed after appending a new element, that remains the same. That is the meaning of word ordered collection. So order here does not mean the name are arranged in some alphabetical order or something, or if there are numbers, say like this, then the numbers must be arranged in 1 to 3. You can write 3 to 1, or you can write 5 and then 1000, and then maybe next can be 1. So any order is fine. So order does not mean ascending order, descending order, or alphabetical order. That thing. Order means that the procedure of accessing individual elements remains same irrespective of how many new elements are added. Okay, so that means that lists are stored in a specific sequence, and the sequence is maintained throughout the life cycle of list. However, these words are also important unless explicitly changed. So that means there is a provision. You can use other functions apart from append. Append will always append at the end, but there are other functions by which you can add a new element somewhere in between. Now then in that case what will happen? That new element will have index 2, and therefore Arya will have index 3 because it will shift towards the right side. So you can explicitly means by coding you can change it, but if it is not changed, then they maintain their sequence. Okay. Now what are the key points of the ordered collection? And there are 4 characteristics of ordered collection. One is every ordered collection can be easily accessed. That means its elements can be easily accessed by indexing. Okay. So ordered collections have by default implicitly index attached. You don't have to attach index by programming. Whenever you populate a list by this, then Python not only creates the list elements, but it also creates index also, that index 0 for this, index 1 for this, and index 2 for this. Okay, so indexing is implicit with every ordered collection. Predictability, as I said, normally you will not be surprised by sudden change in the index. If you are accessing these three elements by index 0, 1, 2, then you will keep on accessing those three elements by 0, 1, 2 index only throughout the life cycle. So the method by which you can access individual elements, that is always predictable. Okay, that is one another important thing. Now, consistent iteration. So you can iterate through a list using a loop or something. Then elements will be processed in the same order as they were added. Okay, so and they are seen also in the same order. If you write print, then they were as they were added. So in that case, if I write a for loop, that for name in name list, print name, then first Alia will be printed, then Mira will be printed, then Arya will be printed. So it is not that first this will be printed, then maybe this will be printed, never. Okay, so printing of the element, that also, or that is being done by iteration, that is being done by for loop, that will also occur in the same order as the list was populated. And you can contrast the ordered collection with unordered collection. For example, set and dictionaries are unordered. Of course, now in dictionary, after 3.7 or from 3.7, dictionaries also have been made ordered. So in them, sets and dictionaries before 3.7, there is no guarantee that the new element which you are adding, that will always be added at the end of the data structure, and therefore you will be able to access the elements in the same manner as earlier. Okay. Now let us start with one very basic thing. I make a list of 3 strings. So my list equals, list is always written by square bracket, and if elements are stringed, then you must put them in quote. You can use single quote, you can use double quote, but you cannot mix quote. That means in Apple, you cannot write these as single quote and this ending quote as double quote, then it will throw error. Now, if I want to access only the Apple, then I can access it in this manner by its index. This is 0, 1, and 2. So I can just write my list and in square bracket 0. So that will output the Apple, and that you can see. But we often want to manipulate the list by more complex manner. So the list has provided several built-in methods, and these are some methods like append, insert, then remove, then pop, reverse, clear, index, count, sort, etc. But there is no need to remember that method. I have shown that repeatedly, and again I am showing that you can just write my underscore list, put a dot, and after the dot, place the tab character, and you can see all methods are visible: append, clear, copy, count, extend, index, insert. Even some method which may not be here, they are also visible. Okay, so there is no need to remember. Of course, the more practice will make it clear that what each method does. Also, if you write, whenever you want to use the method, at that time these are all functions. Method and functions are same, but usually whenever it is built-in, provided with programming language, we call them method. And here, if we define it, then we call it user-defined function. Now, if we want to use some of these, then you have to put a parenthesis. But if you want to find how this is to be used, some help, then you can just put a question mark instead of parenthesis and press enter. So in control enter, and you can get what that function does and everything. Okay. So append the object to the end of the list. So if I just, for example, here 3 fruits are there in my list, and I want to attach a new fruit, say watermelon, then I can just write like this. Then I can write my list and control enter, and you can see that my list has been appended. So now there are 4 fruits. So this is append method. Extend method is more powerful than append, because with extend method you can, so this was the example of append method, but this is the example of extend method. You can add more than one element simultaneously. Here, suppose I want to add 4 fruits in this list, then append cannot do it. Append can do it, but it can do 1 fruit at a time. So I will have to write my fruit, my list dot append, and then watermelon first, then my list dot append second next fruit, then my list dot append next fruit. But with extend, you can do the same thing. Multiple elements can be added in one go. So extend is much more powerful. Okay. Now here, let us first see one example of append only. So this is my list. We will print it, and then we will append a 4th number 4. Okay. Append always attaches the number at the end, and you can see that list has changed. Now let us try to do my list, and now that is try to extend by 5 6. Okay, and remember there is no such rule that numbering should be like in order only. Ordered list collection does not mean that this order, this is the element of the order. What is the meaning of ordered collection that I have shown? So I mean, what I'm saying is first element can be 5, next can be 2, next can be 11, next can be 1, like that. That is possible. Okay, now extend if I use and I directly add 3 elements, then 5 and 6 are directly added. Okay, so this is one important thing. Now, one another important thing is that extend can even be used for adding a single element. So, in a way, you can say that if I know extend, then there is no need to remember append. I can add multiple elements, and this can be as many as you want, or I can add a single element. However, for example, here my list dot extend, and I have added 7. So 1, 2, 3, 4, 5, 6 were there, and I have added one more 7, and then you can see that 7 is added. But there is one important difference between append and extend that you must remember. When you use append, then the new element being added is directly supplied. While when you use extend, then even if you are extending just one element, you have to supply it as a list. So extend takes an argument that is list. For more than one element, it will be, you will always remember it because that is fine. That multiple elements are there, so obviously it will be list. But for single element, also you have to use list if you use extend. Okay. Now how to insert new element? So at present my list is like this. Now I want to insert 0 at the beginning. Then insert is not very simple, because with insert, if I just specify a number, say I specify only this much 0, then how to know where to insert that? That means here or here or here, here. So you have to specify element also, and you have to specify the index also where you are. So here suppose I want to insert at the beginning of the list. So in that case at the 0th index. Currently this has 0th index, but I want to put another element which will have 0th index, and that element also is 0. So then insert and then index and the element which you want to put. Okay, that will put this. Now here the order has changed because this was originally accessed by 0 index and this was accessed by first index. Now it is the 1 is accessed by 1 index and 2 is accessed by index 3. So that was the meaning of that sentence unless explicitly changed. Okay. If you want to remove element, then you can use my list, that is the name of list dot remove, and at that time there is no confusion. You just have to specify only the element itself. For example, here from this list, I want to remove 1. So in that case, I can just write my list dot remove 1. Okay. So let us see what it removes, and then I will try to do another also. My list dot remove maybe 0 again, suppose. Okay, and then this is another method of removing element, so that I am taking to new cell, that is called pop. But first is this. So my list dot remove 1. Even this let me put in other cell. So like this. So currently I have a list which is this, and now I am saying remove 1. Let us see what happens. So this element has been removed. Now what I am interested is in knowing that whether this 1 specifies the index that I want to remove or the element that I want to remove. Now here my problem is that my element at index 1, that is itself 1. Okay, so I will do my list dot remove 1 again, suppose, because now what is at the so I'm trying to remove, say suppose this stands for element at 1, then I'm trying to remove this. So this list has no 1. So let us see what it does. If I execute it, then it shows this error that X is not in the list. It shows value error. So that means this is how you can find whether this is index 1 or whether this is element 1. So if it is index 1, then there is still this 2 at the index 1 in this list. So then 2 should have been removed, but you are actually specifying the element itself. That is what I wanted to show. Okay, so my list dot remove, and then you have to specify that element. But that means you have to be sure that that element is present inside. Otherwise, it throws error. Okay. Then here my list dot pop. Now these 2 pop 2. Now again the question is saying whether 2 means the element 2 or the element at index 2. Here I have put a spoiler that it will remove the element at index 2. But if it removes element 2, then this should be removed. But if it remains element at index 2, then this is 0, this is 2, and this is 1 index, and this is second index. So then 3 should be removed. So let us see what is removed, and you can see 3 is removed. So element 2 is not removed, but element which was at index 2, that is removed, 3 is removed. Okay. So what is the most important difference between remove method and pop method is that remove method we specify the element which we want to remove, and therefore it can throw an error if that element is not present. While in pop method, we specify the index and the element which is located at that index, that will be removed. Okay, so there are two ways of removing something from a list: remove and pop. Even pop method can trigger one error. For example, if I just try a very big index 10, but you know there are not that many elements 0, 1, 2, 3, 4, 5, and 6. So the question is what will happen? Then it will trigger an error, index out of bound error. So index error, pop index out of range. Okay, so then it is clear that you have to specify the index within the capacity of the list, and you can find that capacity easily by using len mylist, len, and that will give how many elements are there in your list, and then you should never exceed more than that. Okay, so that is one another thing. Okay, now let me clear this ugly output. Okay, now sorting and reversing the list. So here I am just printing my list, because if I pop again, then another will be popped, because say this line of code I comment out, because popping of element at index 2 has already been done. You can see that that element has already been popped. Okay, now we want to sort that list. Now this list is already sorted, so even after sorting it will remain same, but I can do reverse sorting. So that means at present it is in ascending order. Suppose I want to sort it in the descending order, then I can do it in two ways. One is this way, that my list dot sort, and in bracket you clarify that reverse is equal to true. So then let us see what happens. You can see that same list has been sorted, but now my list is this. Okay, so now if I again reverse it, and this time I do not use sort, but I use a built-in method called reverse. There is a built-in reverse method also, so I can write my list dot reverse. Then at present my list is like this, descending. So if I again reverse it, then it will again become the original list in ascending order. Okay, what are practical use cases of this list? Then one is it is used. They are ideal for data collection. You can ask user to enter as many things as he wants to, and you can just use a loop for taking input from the user, and you can initiate the loop with empty list. And as the loop goes on executing, that empty list will be filled one by elements which the user is by the input which the user is giving, and any number of inputs can be taken by one single loop. Okay, that is one big advantage. Then it is used in implementation of stack. Stack can be easily implemented using list, because lists are dynamic. So you can add, or what are stacks I am just showing, they are data structure where you can add or remove elements from end. But there is another data structure also, queue. Then list can also be used for implementing queue, but it will be slightly inefficient, because at that time you will need to shift the elements. Okay, but still for small data sets we can use list to implement queue. Now what is this stack and what is this queue? Many other programming languages, like for example C++, Java, C#, they have built-in this data structure also. Just like Python has built-in list and tuple and everything, similarly they have stack and queue also. What are they and what do they do? Let us understand by one example. This one is a stack. Okay, so what it does? Suppose these are individual elements. What this is 0th element, first element, second, third, or if indexing is starting from 1, then 1, 2, 3, and so. Now I am adding a new element here. Okay, so this element would be added here, and now it is not existing. I have added it at the top, because stacks are not accessible from the other end. You can only keep on adding elements from the top. It is just like a stack of book lying on a desk, or that kind of data structure. Now this element was last added, before which this was added, before which this was added, and this element was first added. But now if I use pop to release this element from the stack, then the one which was added last, that will be popped first. Okay, because this will go out first. So this goes out first, and then this will come at top. Then that goes out, and then that goes out. That is why it is said that these these stacks, they are LIFO type of data structures. LIFO means last in, first out. Whosoever enters the stack last, while popping the elements one by one, that goes out at the end. And remember, these stacks are very, very useful data structures. And unfortunately, Python does not have implementation of stack in implicit manner. So you can easily make a stack, but by using list. Now this is what is called queue. Queue is something which is open at both ends, and these are its various elements. So suppose this is 0 index, this is 1 index, zero index went in first, then this third index went in first, then two index went in second, after which this went, after which zero index went. Okay, so indexing may start from that side only. It is possible, so I am just removing that. But in short, this went in first, then after which this went in, after which this went in, and a new element is trying to enter into the queue from behind. Okay, so I am cancelling now this, and I am putting that new element inside only. So this is that new element now. Okay, and it is attached at the end of the queue. But if I pop the element, then which will be popped first? This will be popped first. Okay. Then after, so whatever entered first, that pops first. Whatever entered second, that goes out second. And whatever entered last, that goes out last. So it is not this kind of thing that last in, first out. In fact, it is called FIFO structure. First in, first out. Second in, second out. And last in will be last out. Okay. So this kind of data structure, that is called FIFO. FIFO. Okay, and these QRs are also very important data structures. And by using lists, one can implement queue in Python because they do not have built-in queues. They do not have built-in stacks. So by using lists, you can implement both. But for queue, whenever a new element enters, all these will be pushed towards right side. So that means every element will change its position. That is not the case with stack. When a new element enters, then the position of the rest of the element remains the same. So there is no movement of rest of the elements. So that is why when you implement a stack using list in Python, then stack is efficient. But when you implement a queue using list in Python, then it is not very efficient implementation. But something is better than nothing. Whenever you need a queue, then you have to use list to implement. Okay, that is what is written here. Now in next lecture, we will start with another collection, that is tuples.